Now we're going to look at how the quadrants of our terminal side are going to affect the trig values, particularly sine, cosine, and tangent, of our angles. And we'll notice a pattern in terms of which trig functions are positive or negative in which quadrants. So I'll remind you of the ratios for sine, cosine, and tangent. Sine is y over r, cosine is x over r, tangent is y over x, and a reminder that r is a distance. It's defined to always be positive. Okay, so if we have an angle in standard position that has a terminal side in the first quadrant, x and y are positive in the first quadrant, and therefore sine, cosine, and tangent are all going to be positive. Okay, since if we divide two positive numbers, the result is going to be a positive number. When we move into the second quadrant, now y is positive, but x is negative. So what will happen here is sine is going to be positive because y over r is still positive over positive. But cosine will be negative over positive. Tangent will be positive divided by negative. So cosine and tangent will be negative. So any of the ratios that involve x here will be x divided by a positive or positive divided by x. Since x is negative, then those ratios will be negative. In the third quadrant, x and y are going to be negative, and therefore sine is going to be negative, as will cosine. And so we saw this with an example from the previous video. Sine will be y over r, y is negative, r is positive, their quotient is negative. Cosine is x over r, x is negative, r is positive, their quotient will be negative. Tangent is y over x, y and x are both negative, a negative divided by a negative is positive. Okay, so tangent will be positive. And finally, in quadrant 4, x is positive and y is negative. And therefore sine, which is y over r, will be negative. Tangent, which is x over r, will be positive. And finally, tangent y over x will be negative over positive, which is negative. Okay, so we have that in quadrant 1, sine, cosine, and tangent are positive. In quadrant 2, sine is positive, cosine and tangent are negative. In quadrant 3, sine and cosine are negative, tangent is positive. And finally, in quadrant 4, sine and cosine are, apologies for this. I think I said cosine, but wrote tangent. Sine and tangent are negative, and cosine is positive. Now, there's a mnemonic that we can use, and again, if you've done some trig in high school, you may have seen this in the past. There's a mnemonic that we can use to remember out of sine, cosine, and tangent which trig functions are positive in which quadrants. Yes, you may have seen something like this before. If you haven't, I'll explain it in just a moment. So what we do is take our 4 quadrants and go in counterclockwise. We write A, S, T, C. Mnemonic we can use is all students take calculus. And what this means is that in quadrant 1, all of our trig functions are positive. By all here we mean sine, cosine, and tangent. In quadrant 2, sine is positive, cosine and tangent are negative. In quadrant 3, tangent is positive, sine and cosine are negative. And finally, in quadrant 4, cosine is positive, sine and tangent are negative. Okay, so again, this is just for sine, cosine, and tangent, but then we can look at the reciprocals to get secant, cosecant, and cotangent if we were so inclined. Okay, so this tells us if we have a terminal side in one of the quadrants, what the sign, the plus or minus sign of our trig functions will be. Now we can combine this with the idea of a reference angle. Okay, so every angle that has a terminal side in a quadrant, not on an axis, has a reference angle. Okay, and I'm going to denote this by theta subscript r. Okay, and this is just the acute angle formed by the terminal side of theta and the x-axis. So if we have an angle that terminates in the first quadrant, the reference angle will, if our angle is actually acute and we're not going around the circle a bunch of times, the reference angle will equal the angle itself. Okay, but here, regardless, if we have a terminal side in the first quadrant, the reference angle will be the angle formed by the terminal side of theta and the positive x-axis. If we terminate in the second quadrant, let's suppose here's our angle theta. Our reference angle will be formed by the terminal side of theta and the negative x-axis. If our terminal side is in the third quadrant, the reference angle will be formed by the terminal side of theta and again the negative x-axis. And finally, if our terminal side is in the fourth quadrant, our reference angle will be formed by the terminal side and the positive x-axis again. So again, we're just going to find the acute angle that's formed by our terminal side and the x-axis, either the positive or the negative x-axis, depending on which quadrant we terminate. Okay, and it turns out, and this is why we care about these sorts of things, that every trig function of an angle is equal to either the trig function of its reference angle or the negative of the trig function. So I'll write this as a theorem. So the sine of theta is either equal to the sine of its reference angle or negative the sine of the reference angle. And the same is true for every other trig function. So the cosine of theta is equal to either the cosine of its reference angle or negative the cosine of its reference angle. Okay, and same is true for tangent, cosecant, secant, and cotangent. You want to note that since the reference angles are always acute, the trig values of the reference angles could be formed by just doing a right triangle, and therefore the sine, cosine, and tangent is always going to be positive, because now we're just in right triangle trigonometry. So these trig values are always going to be positive. The ones that have the negatives out front are always going to be negative. And we can determine if we're dealing with the positive or the negative trig value by looking at what quadrant we're in. Okay, so for example, let's suppose we looked at the angle theta equals negative pi over 4. Okay, so that's going to be a 45. I'll write this as negative 45 degrees as well, if you're more comfortable with degree measure. Okay, so this is going to be a 1/8 turn clockwise. Okay, and we see that our reference angle is just going to be pi over 4, or 45 degrees. And again, use whatever measure you're more comfortable with here. Okay, because there's going to be a pi over 4, or 45 degree angle from our terminal side back up to the positive x-axis. And we see that our terminal side is in the fourth quadrant, where cosine is positive, sine and tangent are negative. Okay, therefore, since the sine is negative, sine of negative pi over 4 is going to be negative the sine of pi over 4. So that's going to be the same as negative the sine of 45 degrees, which is negative 1 over root 2, or negative root 2 over 2. So again, the only difference between the sine of negative pi over 4 and the sine of pi over 4 is the negative sign. And we know it's negative because we're in the fourth quadrant, where sine has to be negative. Similarly, cosine cosine of negative pi over 4 is going to be the same as the cosine of pi over 4, because the cosine of negative pi over 4 in the fourth quadrant has to be positive. So again, in the fourth quadrant, cosine is positive. Therefore, the cosine is 1 over root 2, or square root of 2 over 2. And the tangent is going to be negative 1. So remember that the tangent of pi over 4, the tangent of our reference angle, pi over 4, or 45 degrees, is positive 1, but now we're in the fourth quadrant where the tangent is negative. So the tangent is negative 1. Okay, so this is one way that we can do trig functions of angles that have reference angles of 30 degrees, 45 degrees, and 60 degrees, or pi over 6, pi over 4, and pi over 3. We can use quadrants and reference angles. We can say, okay, we can graph our angle, we can figure out what quadrant we're in, we know what the reference angle is and the trig functions of that reference angle, and then we just attach the appropriate plus or minus sign depending on what quadrant we terminate in. And this is a really nice way to do trig functions, and we can come up with a whole table now of trig values all the way around the circle. This is nice because it goes back to right triangle trigonometry, really. Moving forward, we're going to look at another way that we can do trig functions of general angles using what we call the unit circle.